means across diode if we will not take output, those are called series diode configuration. So series diode configuration means output will be taken in series with the diode. And parallel configuration means if we take output here, it is called parallel diode configuration. Across diode if we will take output, that is called parallel diode configuration. So we will start first from this figure. In this figure, they have told that a battery of 12 volt is connected here. A silicon diode is connected here. A 10 ohm resistance is connected here. What is the value of I they want? You can see in this figure the plus point of diode and minus point of diode. Plus point of diode is connected to the minus pin of battery. So it is reverse bias. In the reverse bias, this diode will be open circuit. So if diode will be open, the loop will be open, so no current will flow. So answer will be I will be equals to 0. No current will flow. So in this question, the answer is I is equals to 0 because the diode is reverse biased. Now we will come to this figure B. In this figure, they have asked what is the value of I. Now, in this figure, if you want to know what is the value of I, we have to apply KVL in this loop. We have to apply KVL in this loop. Now, we can understand that this is forward bias because plus of battery is connected to the plus of diode. Minus of battery is connected to the minus of diode. So this is forward bias. Now, this I, you can see this I is coming to this. So I will go like this here. Now here you can see there are two branches. So I1 will go through this. And I2 will go through this. I1 will go through this, I2 will go through this. So I is getting divided into two parts here. I1 will go through this, I2 will go through this. Again they will mix here and they will become I. So if we apply KCL in this node, suppose this is node 1, we can write applying KCL at node 1, we can write I equals to I1 plus I2. I is equals to I1 plus I2. Anywhere if you cannot understand it, please stop me and ask. Now you can see there are two loops. One is two unknowns are there, I1 and I2. So obviously two equations we require. Suppose this is loop 1 and this is loop 2. So I1 is going from bottom to top. So across the resistance, this side plus, this side minus. I2 is going also from bottom to top. So this side plus, this side minus. Silicon, this side plus, this side minus 0.7. This silicon, this side plus, this side minus 0.7. Sorry. So now what you have to do? Please don't mark anything here. don't mark. So if we apply KVL at node 1, in this node if we apply KVL, from any point we can start. Suppose you will start from this point. We start from this point. So minus 2. So write, applying KVL, we can write here. Applying KVL at loop 1. So applying KVL at loop 1, we can get minus 2 plus 20. Then we'll come here, plus 2 minus 20. Current through this is I1, plus 2 minus 0.7 equals to 0. So I1 equals to 19.3 by 20. Means 1.93 by 2 equals to 0.965 milliamps. So I1 is equals to 0.965 milliamps. So I1 equals to 0.965 milliamps. Now you have to find out I2. To get I2, we have to apply KVL at loop 2. So we have to apply KVL in loop 2. Right? Applying KVL at loop 2. If we apply KVL here, from anywhere we can start, plus 2 minus 10 IR, voltage equals to I into R. So R is 10, I is I2. So minus 10 I2. Plus 2 minus 0.7. Then minus 2 plus 0.7. Minus 2 plus 20 I1. Here voltage is 20 I1, I into R equals to 0. So this and this cancel. So I2 equals to 2I1 equals to 1.93 milliamps. So I2 we have got 1.93 milliamps. So I equals to I1 plus I2 equals to 0.965 plus 1.93 equals to, if we add 5, 6, 3, 9, 9, 9, 18, so 8, 2.895 milliamps. understood this?
Yes, sir.
Yeah, when I am writing, you also please write in your copy. Otherwise, later on you will not be able to find out. So this is the second problem. Now for the third problem, we have to find out I1. So here you can see the diodes are connected in opposite direction. So when this side plus, this side minus, battery is connected like this. Silicon diode, this side plus, this side minus. So this is forward bias. This diode, this side minus, this side plus. So this is reverse bias. So this will open. The line is only this. So there is a complete 10 volt drop will be here. Current is going like this. So this side plus, this side minus. If we apply KVL here, minus to plus, plus 10, plus to minus, minus I into R. So 10 into I equals to 0. So I equals to 10 by 10 equals to 1 milliampere. So in C or third problem, current is equals to 1 milliampere. Have you got it?
Yes, sir.
Can I erase this now?
Yes, sir. Yes, sir.
So now problem number 6. In problem number 6, we have used point source. The meaning of point source is, suppose somewhere it is written like this, plus 5. The meaning of this plus 5 is, a battery is connected such a way that plus point of battery is connected to this point, minus point of battery is grounded. This is the symbol of ground. When lines will be, length of line will be decreasing and it will be ended in a point. That is the symbol of the ground. So this is the meaning of plus 5. Plus or big line of the battery is connected to this point pin and minus pin is grounded. If anywhere suppose minus 10 is written, that means a 10 volt battery is connected such a way that minus or small line of battery is connected here, big line or plus pin is connected to ground. So this is the meaning of positive point source and negative point source. Now here you can see in problem 6, the first problem, the minus 5 volt is connected. That means minus point of battery, sir, ଏବେ ନାହିଁ ବହୁତ ଆଗରୁ ହେଇଛି ନାହିଁ सर्टिफिकेट आपको दरकार की फॉर्मेट किसी नहीं से जो केवीडी प्रकाश बनाउछि मु ता कहि दउछि आपन पठे केवीडी प्रकाश हां केवीडी प्रकाश मिले सर्टिफिकेट तो तार पाखरे अछि से एबे भी बनाइछि ना तापर ये एबे भी से बनाइथिले ना तारो जे नो यूनिवर्सिटी पे minus pin of the battery is connected here, plus pin is grounded. So plus pin is connected to ground. So you can see now the circuit is closed loop. So in this circuit you have to find out ID and VO. So ID is current through diode, VO here where they have given across the resistance. So you can see minus pin of diode is connected to the minus of battery. That means forward bias. So diode is on. So current will flow. So if we apply KVL in this loop, the same ID is flowing here also. This side plus of battery 5. This side plus of diode 0.7. So if we apply KVL in this loop, plus to minus minus 5, minus to plus plus 0.7. Current is going from bottom to top, so this side plus, this side minus. So minus to plus, plus resistance is 2.2 and current is ID. So I into R, that is the voltage, equals to 0. So ID equals to 4.3 by 2.2, almost equals to 2 milliampere. Little bit less, maybe 1.98, 1.98. You can use your calculator. ID is almost equals to 2 milliampere. What is VO? You can see VO top side minus, bottom side plus. So it is opposite of our conventional sign taken. We normally take top side plus, bottom side minus. So VO polarity will be negative because now here output is top side minus, bottom side plus. So VO equals to minus ID into 2.2 minus I into R equals to minus 4.3 volt. Why I am writing 4.3? Because it is actually 4.3. From 5 volt, 0.7 will be lost here, 4.3 will get here. So VO equals to minus 4.3 volt. Have you got it?
Yes, sir.
So the next problem. Here supply is plus 8 volt and here minus 6 volt. So two supply is there. So plus 8 volt means plus point of battery is connected here, minus point is grounded. Minus 6 means minus point of battery is connected here, plus point is grounded. So you can connect them and make ground. So this is 8 volt plus minus. This is 6 volt minus plus. Current direction is given like this. So this side plus, this side minus. In this loop, same ID current is flowing. Similarly, if it is like this, then here it is going from left side to right side. So this side plus, this side minus. Same ID current is flowing. So if we want to, this is the 8 volt and this is 6 volt battery. So if we apply KVL in this loop, minus to plus, plus 8, plus to minus, minus IR. So minus 1.2 ID, plus to minus, minus IR. So minus 4.7 ID. This side plus, this side minus 0.7. So plus to minus, minus 0.7, minus to plus, plus 6 equals to 0. So this is the KVL equation. So from here, 8 plus 6, 14, 14 minus 7, 13.3. So 4.7 plus 1.2, 5.9 ID, 5.9 ID equals to 13.3, or ID equals to 13.3 by 5.9. Okay, so some 2-point result will come. 13.3 by 5.9 close to 2.24. Equals to 2.25 million. So ID is 2.25 milliampere. Now what is VO? You have to calculate again. So you have to calculate again. This is VO. VO means at this point, what is the voltage? That is VO. So between this point and ground, what is the voltage? That is VO. So we can apply KVL here. From this ground to this ground, we can apply KVL in any direction. So plus to minus, minus 6, minus to plus, plus 0.7, minus to plus, plus 4.7 ID, plus to minus, minus V naught equals to 0. So V naught equals to 4.7 ID minus 5.3. 4.7 ID minus 5.3. ID is 2.25. So equals to 4.7 into 2.25 minus 5.3. 4.7 into 2.25 minus 5.3 equals to 5.275. 5.275 volt. There are another way you can come. VOE between this point and ground. So you have 8 volt here minus how much you have dropped here. That is your VO. So from this side it will come VO minus 2 plus plus 8 minus 1.2 ID plus 2 minus minus VO equals to 0. So VO equals to 8 minus 1.2 ID. If you will calculate, you will get the same value, 5.275 volt. So from any side you can come, you will get the same result. Got it? Yes or no? Yes. So next problem will go. Determine the VO here. So 12 volt plus 12 volt. Battery is connected like plus point here, minus point is grounded. This is 12. Plus minus. Plus pin is connected to plus of silicon, so silicon is forward bias. Plus of germanium, so germanium is also forward bias. This is minus of silicon, minus of germanium. So as this side plus, current will flow like this. Suppose I current is flowing. So this side plus, this side minus will be polarity here. Here this side plus, this side minus will be polarity. If we apply KVL in this loop, minus 2 plus plus 12, here it is 0.7, germanium 0.3, plus 2 minus minus 0.7, plus 2 minus minus 0.3, plus 2 minus minus 2 into I, plus 2 minus minus 10 into I, plus to 0. Or 10 to 12 I equals to 11. Or I equals to 11 by 12. 11 by 12 equals to 11 by 12 equals to 0.92. 0.92 milli.